Hello everyone, this is lesson 9.2, graphing quadratic equations in vertex form. So today you're going to learn more about the new type of quadratic equation, vertex form. Previously we did standard form, that was ax squared plus bx plus c. This one is different, as you learned in the investigation. If you haven't done the investigation for Wednesday's work, make sure that you do that, but it might be helpful to watch this video first and then do the investigation if you're an e-learner. So what you did is you plugged these into Desmos, and you discovered that the number in front, like the 2, the 1/2, that determines how wide or narrow the graph is. So if it's a fraction less between 0 and 1, then it's going to be wider. If it's bigger than 1, it's going to be narrower. And if it's just 1 or -1, then it's going to be the same steepness. We're comparing it to the equation y equals x squared, remember. So the x squared has a coefficient, an a value of 1. And then the other numbers here represent the vertex. So this 4 and the -3, you would take the opposite sign in the parentheses and the same sign that's outside of the parentheses. Okay, which also means that the axis of symmetry would be x equals 4. So another thing I'm going to ask you to start doing now in your Edgelastics is not just to graph the equation, but also to graph that axis of symmetry, that vertical line that passes through the vertex, because that's going to allow us to get a better picture of the symmetry of the graph. All right, so today we're just going to practice on taking the information that you learn, like these examples that you did in Edgelastic, and putting them onto the graph. All right, so for number 1, it says y equals x minus 1 plus 2. So we would first want to figure out the vertex. So the vertex will be 1, 2, which means the axis of symmetry will be x equals 1. Since this parabola is positive in front, then it's going to be opening up, which means that the vertex is going to be a min. So to graph this, I'm going to first graph my axis of symmetry line. So I'm just going to use this little dotted line here at x equals 1. So that would be this right here. So if you have a highlighter or something or a different color in utensil, you might want to do that for your axis of symmetry line. Okay, and then we're going to plot the vertex like we normally would. So 1, 2. So 1, 2, and then this parabola is opening up. So the other way we can get another point is we could figure out what the y-intercept would be. The y-intercept is when x equals 0. So you would disregard this x, I guess, and you would do -1 squared plus 2, which is 1, positive 1 plus 2, which is 3. So the y-intercept is 0, 3. So if it's 0, 3 on this side, it's also going to be 2, 3 on this side. Okay, and then you only need 1 point for graphing in Desmos, but if you were doing this on paper, you might want to get another point, and in order to do that, you would look at your graphing calculator. So I would type this equation into my y equals x minus 1, don't forget the squared part, plus 2. Look at the table. So what would it be 1 unit over? So at -1 and 3. So -1 and 3, you're at 6. So I can also graph -1, 6, and 3, 6, the mirror point. Okay, that just gives me a better picture of the graph. And I might be able to do this better if oh gosh. So hopefully your parabola looks a little bit neater than mine. Well, that wasn't too bad. Okay, next question. So here, and notice that this would have the same steepness as the parent function because the a is 1. All right, so here our vertex would be +2, +5. Opposite sign, same sign. Your axis of symmetry then is x equals 2. The parabola is opening up again because it's positive, so the vertex will also be a min. So let's graph our axis of symmetry. at x equals 2. Plot your vertex at 2, 4. What was it, 2, 4? 2, 5. 1, 2, 3, 4, 5. And then if I try to find the y-intercept, it's not going to show up on the graph because this would be 2 squared, which is 4, times 2 is 8, plus 5 is 13. So instead, I could figure out what just 1 unit over is. So I think the easiest way to do this and to avoid mistakes is just to type the equation into your y equals. So look at the table. So we have x, and then, what was it, minus 2 squared plus 5. Second table, see, at the y-intercept is at 13, like I was saying, but the next one over is at 7, so we could graph that point. So 7 on this side, 7 on that side, and then draw your parabola. Okay, and then also I would just want to mention that the nice thing about the equations in vertex form is that with the graphing, you don't have to use negative b over 2a. The vertex is just right in front of you. Okay, so just keep that in mind. Vertex form is the easiest one to graph. Okay, so the rest of this is pretty much the same. Let's see, I might do one more example with you guys. So, and just this will be a question for you. So what would be the vertex in question 3? Okay, the vertex in question 3, opposite sign, same sign, -7, -8. Your axis of symmetry then would be the equation x equals -7. And then this parabola is opening down because this leading coefficient is negative. So it would be, the vertex would be a max. Okay, so I'm going to graph my vertex. Actually, graph your axis of symmetry first at -7. And then plot your vertex at -7, -8. And then this parabola is going to be opening down. So we're going to need another point on the right or the left. So I'm just going to go ahead and type it into y equals. We've got -3 x plus 7 squared minus 8, second table, and I will identify my vertex right there. And the next point over, which remember that if you're doing this in Desmos, the next point over, if it's facing down, you want to choose to the left. If you choose it to the right, it'll make it go sideways, and then you could just move it back over to its mirror point. Okay, so the next point over would be at -11 on both sides. So -11, -11. And I'll give you a little hint. So if you notice, -8 and -11 are 3 units away. So the first point over from the vertex is always going to be however many units the A is. So if the A is -3, it's going to be down 3. It's kind of like slope, except it doesn't keep going like that. It doesn't keep going like down 3 over 1. It keeps going further down over, because that's the quadratic, but it's not linear. But the first point over is always going to be a down 3 over 1 based off of what this number is. If this number is -1/2, it's going to go down 1/2 over 1. So it would be like right there, for example. Okay, so that's a little trick for figuring out what the next point over would be. Okay, if we look back at this example, for say, here's the vertex, the leading coefficient is 2, and the next point over is up 2 over 1. Okay, this one's leading coefficient is 1, and the next point over is up 1 over 1. So that's a slope of 1. But see, the next point over would be up 3 over 1. So it doesn't work if you keep going, it just works for the first one. So I hope that makes sense and maybe helps you as you're figuring out the next points. Okay, so we're going to do another really important question, and that's being able to write the equation of the parabola in vertex form. So given the graph, what is the equation? So here's how we would do this one. So the first thing you would want to do is, so kind of like what I was saying about the next point over is like the slope, and that's your A value. So here, to figure out the a value, we would go from the vertex and we would go up however many over 1. So how many up do we go? It's a little bit hard to tell here, but we're going to assume this is a fourth. Okay, so here your a is going to be 1/4. And I'm just going to go ahead and do the same thing for each one. Here, I'm going down 1 over 1 to get to my next point over. So that a value would be -1. And this one, you're going up 1 over 1 to get to the next point from the vertex. So that a value would be +1. Now, let's say what our vertexes will be. Because if you want to write in vertex form, you need to know the vertex. So here, this one will be 0, 0. This one will be over 2 up 0. And this one will also be over 2 up 0. So I guess these aren't the best examples, but they'll work for now. So here our equation would be y equals our a, which is -1/4, times x minus 0 squared plus 0. Now, do we really need those zeros? No. So let's simplify this a little bit. Y equals -1/4, and this is just going to be x squared. Okay, so this is just a simplified version of the vertex form since you have zeros. Okay, for the next one, we would do y equals -1 times x, and then remember, it's the opposite sign, so it's -2 squared plus 0, which we don't really need. Okay, oh, I don't know why it keeps going sideways, backwards. What on earth? Oh, I see, I was accidentally pressing a button on my keyboard. Okay, and then the next question, we would have y equals +1 times x, and then the same thing, -2 squared plus 0, so you don't need the 0 part. All right, and then just a couple questions. Write the vertex form of a quadratic equation, so that's y equals a times x minus h squared plus k. What does changing the a value do to the graph of the quadratic? Okay, so answer that question. The a makes it wider or narrower. If h is positive, how does the parabola move? So if this is, and we're just saying if the value of h is positive, like in vertex form, well, h is the x-coordinate of the vertex, so it makes it move to the right. So for positive, it makes it move to the right, and then for negative, it makes it move to the left. What does changing the value of k do to the graph of quadratic? It moves the vertex up or down because it represents the y-coordinate of the vertex. Moves vertex up or down. And then what conclusion can you make about the variables h and k together? They are the vertex point. They are the vertex point. All right, let's see if I want to do any more examples for now. I don't think so. So I think you have everything you need for tomorrow's assignment where you're going to be graphing equations and then also writing the equation given the graph. Okay, so I hope you guys have a great day.